Kia ora Year 13 and Year 12. This is part C and then part D of the question in the Walker book about the mini pizzas and the stuffed potatoes. So you need to have watched the first video or done it and gone through the worked solutions. Question 1C looks at changing one of the constraints, and it says by how much would they have to increase their oven capacity for it to no longer be, not by, a constraint on the number of mini pizzas and stuffed potatoes made. So remember where we got to is that we had our optimal combination was 2416, and our oven constraint, or sorry, not our oven constraint, yeah, it was our oven constraint, was x plus y had to be less than or equal to 40. So you can see that here we've got x plus y is equal to 40. So we're sitting on that constraint. Let's hop over to the graph and have a look at what we're trying to figure out. Where's the graph gone? Here's the graph. So which of those lines is x plus y is less than or equal to 40? Well, you can see that it's this line here. Let's try a different coloured pen. Different coloured pen, not coming, just a sec. Right. This line here, this straight line here, is the one that's the x plus y less than or equal to 40. And at the moment, this is our optimal point of 2416. So what the question's asking us is if we start to shift that line out, how far do we have to shift it so that it's not the one that's constraining what the shop does? Well, let's look at what's going on graphically. This constraint has got a slope of -1. So we want to push that line out further. So if we push it to here, let's just draw that on like that. Is the constraint still binding? Well, yes, it is, right? This is going to be the new point. So what we have to do is to keep pushing that line out in this direction until it isn't going to be what's stopping us making more money. And that's going to happen at this point here. Okay, so if I take my ruler and I just slide it out like this, then that's how far we need to go. So what we're asking is, let's get rid of the ruler and let's clean up these lines. Where is this point where the oven capacity is not what's holding me back? Well, it's at the intersection of two of the other constraints. It's at the intersection of this one and of this vertical one here. So this line has the equation x equals 30, and this purple line here is the one about time. So it's x plus 3y is equal to 72. So now hopefully you're seeing why I made you do all that early work at just being really, really good with figuring out all the equations and what was going where. We can solve this to find the intersection point here, or we can just do it visually. You can see that when x is 30, y is 14, and then you can check it in here. So 30 plus 42 gives me 72. So at this new point, what does my oven capacity have to be? Well, we've just about answered our question. If we have x equals 30 and y equals 14, my oven capacity must be x plus y is equal to 44. So if I increase the oven capacity by 4 units, what's going to happen? Well, this is going to be my new point. Right, so no longer will I be stuck with 24 and 16. I'll change what I do, and it will be 30 and 14. So the second part of the question, I think, asked us to look at what the profit would do. Yep. So assuming they left the profits on mini pizzas and stuffed potatoes at the old prices, how would their profit change? So we'll have, let's see, 50 cents times 30. Sorry guys, I don't know what happened there. We had 50 cents times 30, and then we had 75 cents times 14. So that gives me, I think that gives me $10.50. And that gives me a total profit of $25.50. So you can see that by increasing the oven capacity, what's happened to the profit? Well, it's gone from $24 up to $25.50. Okay, so that's how we can start to play around with a constraint not being binding. And the best way to do that is to have a really good intuition for what all of the lines are on that graph. So the next question was this one. Where's it gone? Okay, so I haven't typed this all out from the Walker book, but hopefully if you're watching this, you've got the book in front of you. What they want to do here is they want to change the profits. They don't want to increase the oven capacity. So basically they're going to try and leave the potato price at 75 cents, but they're going to think about increasing the price on the pizzas. So we don't know what that price will be. And what they want to do is to figure out what price to give the same profit and the maximum profit at C and D. So let's go back to the graph and see which points we're talking about. Here's the graph. Let's take all of that stuff off. So points C and D are these 2 points here. This one and this one. Okay, so what they're asking is about the slope of the objective function. So if you've understood part B, this question's actually not that bad. What we're looking for is to say, well, what are the coordinates of point C? So point C is 24, 16. And what are the coordinates of point D? Well, that's 30, 10. So in order for the profits to be equal at those 2 points, what we need is we need to have our objective function be our profit line is going to slide out from the origin, and as profits increase, we want it to hit all of the integer points along that line segment CD. So that means that its gradient has got to be the same. So getting rid of the ruler now, what have I got for the gradient of CD? Well, it's pretty easy to spot on the graph. We go down 6 and we go out 6. So here, the change in y is negative 6, and the change in x from 24 to 30 is up 6. So m is equal to negative 1. If I want to get a gradient of negative 1, we can do a bit of algebra to do this, or we can just look at it and see. So my new profit function is going to be equal to kx plus 0.75y. The way to get the gradient being negative 1 is going to be to have this equal to this. So some of you will be able to see that from looking, but some of you won't. So I'm going to do a wee bit of algebra just to show you what I'm doing here to get this, because you might have a different question where you didn't have a nice easy gradient. So we've got P is equal to this unknown price plus 3/4 y. So we're going to do our rearranging thing again. This is a huge amount of work though, so it's much easier if you can just see it intuitively. And what we've got here is we know that we want to have m is equal to negative 1. So we can solve negative 1 is equal to negative 4/3 times k. Remember, k is just the price that we don't know yet of the, what are the first things? Are they pizzas? Yep, price of the pizzas. So multiplying that through, we get negative 3 over negative 4 is equal to k. K is equal to 0.75. Okay, so if they charge 75 cents for both the pizzas and the potatoes, then, looking back at the graph one last time, then both points C and D are going to give me the same amount of profit. Now, what other points are also going to give me the same profit? Well, again, if you've understood the last video with the multiple solutions, this bit of the question is pretty easy. What we have to look at, and I'm going to try and enlarge the graph, let's see if we can do that. Should be able to. Here we are. We're looking for the integer valued solutions along that line between C and D. Now, bear in mind that this graph has got a scale where each little square is 2. So these are all integer value solutions, but so are these ones here. It comes back again to a good understanding of the gradient. The gradient's -1. So here's my table. Here's my x and here's my y. I'm starting at 24, 16, and I'm going to end up at 30 and 10. I'm not interested in decimal solutions, but I can see that if I go across 1, up to 25, and down 1, I've got an integer solution. So all of these combos, oh, and I haven't got room for the last one, we'll just stick it down the bottom out of order. There we are. All of those combinations are going to give me the same profit if my new price is 75 cents. Alright, so intuitively, one last time, if I've got the same price for the two goods, then the gradient is going to be -1. Right, the trade-off between the two things is 1 for 1. Right, whereas when we started out with this, we had 0.5, we had 50 cents compared to 75 cents. So that meant that the trade-off was, if we had one more of one, we had 2/3 less of the other, holding the profit constant. Okay, so that's that question done. I'm going to go on shortly and do the next one, which is about Edu assembling electronics kits, and then I'll look at some of the practice tasks. So let me know if you've got any questions or comments on this one, and I'm also going to post the work solutions to my Google Classroom.